where you guys work with all those fractional exponents, and that first page was solve the equations. You've done this. This shouldn't take very long to go through. Just a couple of quick examples here. What I want to do here is just kind of remind us, how do you work backwards to solve for x? And cube it, right. So one of the things that we're looking at being able to do is just you're working backwards to solve an equation like you have in the past. In this case here, you're adding 4. And then you cube it. Okay? And like we've done before with these things, you always want to double check and make sure it's not an extraneous solution. So what's the cube root of 64? 4. It's 4 minus 4. Yay! So it works out. Like I said, you guys should be pleasantly surprised at how quickly and easily a lot of this stuff works.
Always check for
Yeah, you always want to check extraneous for these things. 2x to the 3 halves equals 250.
Divide by 2.
Divide by 2. Good. Now, at this point, do you remember how you undo the fractional exponent? The reciprocal exponent. You go to the 2/3. So this means x is going to equal the cube root of 125, which is
5.
square it.
25.
Yep, you substitute back in 25 to the 3 halves. Well, that means what's the square root of 25?
5.
What's 5 cubed? Then double it.
Only worry about
Does it work?
positive answers.
I'm sorry, what's that?
Only worry about positive answers.
Yes, because you're not, because you're taking a fractional, you're not doing plus minus on this one. If it was like to the 4th, you took a 4th root, then you have to go plus minus. In this case, fractionals, you're just looking at literals. Like I said, you guys should be. All right. Now what?
Subtract 2 and then square it. What? -2? Square inside, right?
Ah, whoa, whoa, whoa! You're squaring. You're not square rooting.
Oh, and then so it's 6. So 4 is equal to that.
Okay. What's 4 times 4?
16.
16 minus 7.
9.
Square root.
3.
3 plus 2.
5.
Did it work?
Yeah.
Okay.
This is fun. This is the type of math I learned.
Alright. Now this one you've got the square root of negative 2x, or excuse me, square root of positive 2x minus 3 equals x minus 3. Don't kill puppies, right? So what do you have to do on both sides?
So x squared minus 6x.
Set aside equal to 0. And what times what's positive 12? Yeah, negative 8.
Negative 6 and negative 6.
So zeros are at 6 and 2. So you go back and double check.
6 does it.
Well, 6 times 2 is what?
12.
12. 12 minus 3 is? What's the square root of 9?
3.
And what's 6 minus 3?
3.
6 works.
Oh, I don't,
It does work.
You only worry about plus minus if you're taking the square root over equal. Here you're just saying it equals this.
Oh, yeah, so it doesn't matter. Two doesn't.
The 2 doesn't work here, and listen why it doesn't work. 2 times 2 is 4 minus 3 is, what's the square root of 1? 1. What's 2 minus 3? Negative 1 doesn't equal 1, does it? That's why it doesn't work. So 2 is your, very good. 2 would be your extraneous solution. It's the solution that's not the solution of the solution.
I like that. I like that.
Okay? Doo-doo. This is where people are going to run into problems here.
Yeah, I think you just had it up.
No problems here.
Well, good. So we have
I
2.
really don't know.
Right?
Yeah.
Can't square it yet because I still have that 2 on the one side. You okay with that?
Yeah.
Yeah, that makes sense.
Now square it.
Oh, and then it's just like.
Wait, how do you do what? How do you?
All I did was, because you have to divide by 2, right?
Oh,
So this same thing is
just take
multiplying by a half.
Oh.
Yeah, I didn't.
So now you gotta FOIL that. What's 1/2 times 1/2? 1/4. So you have 1/4. You wind up with that again here. You get 1/2 times 1/2, and then you double it. So you have 1/4 plus a quarter. You get 1/2 plus 1/4.
I did that, or I like, or I did x plus 1 squared and 2 squared.
That'll work. Subtract out the 1 and subtract out the 4. Now, when you do that, you have negative 1/4 x to the 4th. When I subtract the 1, I get minus 1/2 x. When I subtract the 4, I'm going to subtract 16 over 4. Okay with that?
Yeah.
Yeah.
Sorry, I don't know. Yeah. You know what I hate doing? I hate listening to myself on the recorder. Ugh.
Stop talking.
Well, yeah, I know.
I'm joking.
I say some stupid stuff.
Me too.
Wait, Mr. Murphy,
It's a goose.
What?
It is?
I just like,
Where?
I just had x plus 1 and then x plus 1 over 2, and I squared that, and then I just took it to the numerator and denominator, and I got a bunch of meter stuff.
You can't do that.
Why not?
Because you got a plus sign in there. You can't just distribute that out. That's a whole term. It's junk squared is junk times junk.
No, I did. I distributed it out. I got x plus 1 times x plus 1, right? So I got x squared plus 2x plus 1 over 4 because 2 squared.
Mhm.
And then I multiplied by 4, and then I distributed that.
You can't, oh, I see what you're saying. You did this.
Yeah, and I squared it.
Okay. You can't do that by squaring the numerator, leaving this down here, just making it a 4.
Why not?
Because what happens is this is the same thing as x over 2 plus 1/2. You have to distribute it through. That's what I did here.
What do you mean distribute it? Bring it to the 2 and the 2?
Yes, sir.
So
Because everything is being divided by 2.
So then it would be 8?
It's not 8.
But it would be 4 plus 4.
No.
2
Wait.
squared plus 2 squared.
There's no. Where's this 2 squared coming from? I haven't brought.
The 2 2's on the bottom. We're going to do the squared.
No. You don't square this down. This is x over. Let me write it as 1/2 x plus 1/2 times 1/2 x plus 1/2. Okay. You're foiling out with the fractional coefficients.
Did you do that?
Okay.
Oh, I got it.
I thought that like with all those rules we learned, I thought that like
Yeah,
A over B, I thought that A over B quantity squared is equal to A squared over B squared.
What's in between them? It's a plus sign in this case. Those rules don't work because of the plus sign. Those rules work when it's a monomial where things are being multiplied together.
Alright.
Does that make sense?
So square.
Yes, ma'am.
So at this point, can we pull out a Twitter?
Yeah, you can do that.
You end up with x squared minus 2x minus 4.
Yeah. There you go. First rule is GCF. What's GCF in this case? It's quarter. Y'all had a quarter in there. And since I'm solving for a 0 in this case, can I get rid of the quarter now?
Wait, but this is still on what?
I think at 15, we can take out.
I think it was the wrong right.
Except for about this.
It's the wrong right term.
It just didn't have any get besides that, and then I got x minus 5, x plus 3.
Because now the reason that the quarter can go away is because we're looking for zeros.
I don't even want to check.
And like I was saying, you did the wrong right thing. Instead of turning left, you made 3 right turns. It's not the algebraically sound way, but it wasn't the completely wrong way. Does that make sense?
Will I get the right answer if I do it like that?
I don't know. It could have been dumb luck because of the 2s.
Alright.
All right, that's why I don't want to do general. I don't like doing generalizations like that. All right, so in this case, you have 5 and negative 3.
5 or.
Well, you're sitting here complaining, I don't want to do all this checking in here. Well, what's 5 plus 4?
Oh, I thought it was.
9.
Yeah, I
What's the square root of 9?
3.
3. What's 2 times 3?
6.
What's 6 minus 1?
5.
It worked. What's negative 3 plus 4?
Wait, 1.
What's the square root of 1?
1.
What's 1 times 2?
2.
What's 2 minus 1?
1.
Did that work?
Yeah, I didn't, wait, I didn't, wait, no.
No, it's negative 3.
No, it was negative 3. But when I said that, I didn't look at the actual starting equation. I was looking at like the half one. I don't know what it's like.
I hope none of you guys get this. Excuse me. Wow. All right, let's do another one.
Actually, she can come
I
around.
missed 2 days.
Hopefully did not kill a puppy. 7 side equal to 0. X squared, 7x, and a 12. 5 and 2?
Oh, I got negative 3 and negative. Yeah, I got 3 and 4. I got negative 3 and 4. That equals 10. Negative
I have been
3.
gone too long, apparently.
Negative 3 and negative 4. No. It's
Well, then it's a positive 3 and 5.
oh, duh.
Oh, wait.
So your zeros are negative 3 and negative 4. I was just checking to see if you were paying attention.
Sure.
Let's see. 3 times negative 3 is negative 9. Negative 9 and 13 is 4. Square root of 4 is 2. Negative 3 plus 5 is 2. That works.
Wait.
Negative 4 times 3 is negative 12. Negative 12 and 13 is 1. Square root of 1 is 1. Negative 4 and 5 is
1.
They both work. Wait for you to really do the seal sound so you go, "Arr, arr, 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 arr." Oh no! Fraction exponent.
Take the fifth. Take the fifth rule.
I'm multiplying. Raise it.
I mean, raisins to the 5th? Yes. Definitely
I'm tired of using
So when you walk through it, 2x minus 1 to the 5th is 1. How do you undo a fractional exponent again, guys?
Multiply it by the reciprocal.
Raise it to the reciprocal. Always raise your go to the reciprocal. 1 to the 5th power is
1.
Yeah, just make it big.
X is 1. X is 3. Little error there. So you don't mess up.
I swear, everyone, that's what I say.
2 times 1 is
2.
minus 1 is.
Wait, 17.
1.
64.
I want to know. Oh, no, I don't even know what you said now.
So why do you keep saying things then?
Go back to, oh, the lights went out. It's like,
I don't know. Okay, no, I'm no longer allowed to be sick and dying. Claire, come back. We miss you.
You're the only sane person.
She's not going to watch the video because she doesn't care about school. I actually didn't hear that. Don't watch the video. I didn't say that.
why do you keep talking?
Claire, I love you.
I think your fashion sense is really weird. Yes.
I already got this. You think Claire's? That's like the weirdest thing. Claire, I think
You're this thing on the door. You're in